All right, welcome everybody. I am going to introduce Cory Sabol. He is our speaker for today. I'm going to be talking about fortifying AI data pipelines. So I'm just going to hand this directly over to you, Cory.
All right,
that's okay. And then I will chime in if I have some questions. Also, if anybody else has questions, please leave them. Just go ahead and type them into the chat, and I will address them with Cory so he doesn't have to keep staring at the messages there.
I appreciate that. So as Jason said, I've been here for quite a while and done, you might know me from the container Kubernetes stuff I've done, but again, part of my formal education was machine learning and AI related stuff. And then I went a long time without doing anything with that. And then I kind of
decided, then ChatGPT came out and everybody go, oh, look, there's this really cool stuff.
Yeah. And I was like, okay, let me dust this off and kind of dive back into that. And it's like, oh yeah, I mean, it's very helpful that I had that background, right?
Yeah.
For digging into that. So what we're going to talk about today is the concept of fortifying AI data pipelines and how that relates to, AI related applications. And real quick on the slide deck here, there's a little bit of contact information, right? For me, you can email me, Cory@securiteas.com. If you have questions, inquiries about whatever, you can find me on Twitter. I'll say I mostly just post game development related stuff because that's one of my hobbies. And every now and then I will drop some hacker, security wisdom, so to speak, right? I think that's what a lot of people followed me for, and then they're like, "Oh, it's just pixel art." And then we have a public professional evil Slack. So if you haven't joined that, definitely urge you to join that. You can chat with us in there. Myself, Jason, and some of the other consultants. We just hang out there every now and then, check that, and talk about whatever security mostly. But
a lot of our CISP students hang out there.
Yeah, exactly. Okay, so just the agenda for today's webcast, right? We're going to talk about the importance of AI data pipeline security, right? Like, why should you care about, where the data is coming from that your model is trained on? What are the implications of failures to, handle that data properly, to, know where it's coming from, to, sanitize it and scrutinize it. Then we'll talk about the OWASP LLM top 10, right? We'll just do an overview of that real quick, just to kind of familiarize you with it. OWASP has been putting some efforts into generative AI, security, with, again, the OWASP LLM top 10, which is very similar to the web application top 10, for example, which, many of you are probably familiar with. And some other things like governance guidelines and things like that, right? So we'll just go over that really quickly, again, to familiarize you with it. And then we'll talk about the two specific, what I think are the two specific elements from that list that really apply to the concept of, the data pipeline security, which is model training data poisoning and supply chain vulnerabilities. But specifically with the supply chain vulnerabilities, we'll focus in on the models themselves and the data that was used to train them. And then we'll just talk about, we'll look at some examples kind of how things can go wrong, right? And talk about how to mitigate them, right? That sort of thing. It'll be kind of casual, right? We're going to just, talk it out, right? And discuss this topic. And then, we'll have some time for any questions and whatnot.
Yeah. That said, if you do have questions in the middle of it, just go ahead and type them in.
Yeah, absolutely. I mean, because that's great. You might prompt us to be like, oh, that's really good to think about. And then we have an interesting little chat about it.
Exactly.
So don't, exactly. As Jason said, don't hesitate. You don't have to wait till the end to ask questions, but there will be some time at the end just in case you didn't. Okay. So let's talk about the importance of securing AI data pipelines, right? So at a high level, there's a couple of reasons why AI data security matters, right? For one, a lot of this is similar to, you have all of the same concerns you have with any kind of data protection already, right? But then, so protecting sensitive data, for example, right? are we training the model on potentially sensitive data? Now we have to think about, okay, what are the downstream implications of that, right? I don't know, was PII included in the data set, right, in some manner? And now we have to be careful to make sure either we need to retrain the model or fine tune it, or, right, there's techniques to edit models to make sure we don't leak that data to other users of the model, right? What's the context of the use case? Is it publicly accessible, or is this for an internal system where the end users are expected to be privy to that data, right?
Yeah, I'm sure you're going to get into this. And just to be clear, I have not seen this presentation yet. I've just flipped through the slides, but I don't know exactly what Cory has in mind. So I'm sure he's probably going to cover this. But Cory, so one of the things that I find interesting, and maybe this is the crux of this, because like you're saying, like, we're still protecting data. That part of the problem hasn't changed just because we're using AI.
Right.
It's still one of the things that we're focused on. But I think part of the problem is, if you look at a non-AI system, like let's say a database, or a file system, we have very specific ways that we can protect that data. Like we can put ACLs on things.
Right.
And so, okay, there's all this data here, but these users can only see this part of the data, and these other users can only see that part of the data. And that's sort of like, you have that, but you don't really have that type of control in an AI system, do you?
Exactly. So, right, that would kind of fall under this, like, right, this risks that are associated with, integrating AI deployments into your systems, the model integrity, the reliability. But yeah, we don't have, for example, LLMs are non-deterministic, right? So that's an excellent example with the database. I often sort of think of LLMs as like these weird vector, they're not vector databases, but I think of them as like these data stores, right? Because the knowledge and data is stored in there in a certain manner, to the point that people have been able to use large language models as a compression, medium, right, for data. And so we have this non-deterministic way of accessing that data and knowledge, right? Whereas with a typical database, right, a relational database, or whatever NoSQL database, we can put those deterministic rules in place for what we get out of it, right, and what certain users get out of it.
Yeah.
And so that's an excellent point to bring up, because this changes the nature of the problem downstream, right? And we have to be much more careful about what data is going in there, because it's very difficult to predict how that's going to actually manifest once the model's in use.
Yeah.
And
we
so
have a question in the chat too that's related, I think.
Yeah. The question by Fausto is, could we treat the AI as a person type that is accessing data/information, put the ACLs on the target data? So that's an excellent point. And that falls kind of into the idea of treating AI models as agents, right? But you still have the issue in a way of, you have to think about, with all of this, it's contextual, right? It's like, where is the model situated in the architecture, and how is it accessed, right? Treating it as an agent, it's like a whole other, I think, suite of issues, where we have to think about, but I think treating it as like a person, right, that maybe has privileged access to a database and certain APIs. Now we have to think about how can attackers maybe manipulate that person, right, to do malicious things with the things it has access to. But with the data security itself, we have to think about, okay, what knowledge, so to speak, is contained within the model itself, and be careful with, whether or not that leaks,
I think part of, and go ahead and correct me if I'm wrong, because I know you know more than I do about this. So
I don't know.
But what I was thinking is that, in answer to that question, I think part of that depends on if the data that you're referring to is just used as part of the context in a query,
right,
or in a session, right? If it's just part of the context, like if there's a new, I don't know how long it's been around actually, but it's becoming popular new set of LLM integration like style of tools called RAG, retrieval augmented
generation.
I think. Yeah. Figured something like that.
Exactly.
And then the whole idea there is you don't train the AI on a set of documents. Like documents this is a good use case for it.
Yeah.
But you would make those available to that model's context so that it has them as a point, as a reference. And I think in that case, doing the person type of accessing might actually work.
Yeah, exactly.
Because you would just remove from context things that person wouldn't have access to. And then so that wouldn't factor into the context.
Yep. Yeah, I think architecturally like that, what you would do is instead of giving the model like its own account, you essentially you pass on the end user's ACLs, right? So the model can only do what the end user could do. And so it only has access to whatever they should have access to.
Yeah. Problem is that's not the only way people use these things. So.
Exactly, right. And so we have that concept of data with retrieval augmented generation, which that data can be poisoned as well. And that's a concern, and that leads to more like indirect prompt injection, which actually I do have a great blog post on prompt injection. Right, we should probably throw that in the in the chat because I actually talk about that exact kind of scenario in there in detail with good technical bits as well and some code examples that you can play with. But yeah, so we'll move on. Again, so we want to think about, we have this data, right? And if we think about how large language models are trained, right? You have a couple of scenarios. You have usually some organization or company goes, we're going to build a pre-trained, large language model, and they gather tons of data and they have a bunch of access to compute resources, GPUs usually, and they fine tune or they train this model on this vast amount of data so that it encodes patterns between all these different topics and stuff, right? So generally that data is going to be very general and cover a lot of different topics, right? And that's where you get these pre-trained models that you can go, for example, and get like the Llama 3 model, right, from Meta. You can download that model. It's open source. There's asterisks around that, but right. So you can get that model. They pre-trained it. And then there's the concept of fine tuning, right? So you could take a pre-trained model and get some more data, and you can continue to train it on that more specific data, which then trains the model to, bias towards more specific ideas, more specific concepts and responses, right? In both of these cases, we have to think about where did that data come from and what's contained in it, right? If you think about, okay, I'm going to pre-train a model, you might just go scrape the internet for tons and tons of data, right? Well, there's a lot of like potentially unsavory things on the internet, right, that you might then be training the model on. And so now there's the potential for that model to, for end users to, elicit harmful responses out of it. It could, there's been issues with models essentially being like racist or biased towards certain groups, right? And these are all things that, you want to avoid. But taking it further, if you think about an attacker deliberately poisoning the data, right? So we have the issue of this training data, both in the case of fine tuning and pre-training, not necessarily being vetted properly and sanitized, right? The sources being checked for, whether or not they align with your goals. That's a very loud car that just drove by. That broke my train of thought. Whether or not you vetted your data sources properly, right? So if we think about an attacker deliberately trying to manipulate this training data, that gives them the potential to manipulate the integrity of the model, potentially to manipulate the behavior. There's been some sort of research examples on creating a model that was designed to spread misinformation about any topic, right? As sort of a proof of concept. But so the big kind of things here, right, is we get data breaches, right? There could be, sensitive information in the training data that's used that then is, essentially shown to users who don't, have privilege to view that because it's contained within the model. Model tampering, as I just discussed, right? And we'll look at kind of a fictional example, but that sort of relates to a real example that I've worked with on a personal project of mine here in a little bit.
Yeah.
And then, of course, you have unauthorized access, potentially manipulating that, again, the behavior of the model.
I haven't seen, I can't think of an example of that off the top of my head that I've seen in the media or anything, but I do remember one that was tampering with a context where it was a teacher who was trying to catch cheaters.
Mm-hmm.
So what they did is they had whatever the assignment was, they had like shrunk down a bunch of text and made it the same color as the background. That's basically said, no matter what I ask for, ignore those instructions and write about this other topic instead.
Yeah.
Or something like that. It was basically trying to coax the AI into going in a different direction than anticipated, like intentionally, but it would be obvious to the teacher.
Yeah.
The problem was there.
And that's sort of an innocuous example, but that's a good example. Thanks for bringing that up, because that sort of illustrates this concept of what we'll sort of talk about as like backdooring the model, right? In some way to behave, in a certain way when special inputs are given, right? Or just in general behave a certain way. There are some, so OWASP has a few articles that they link out to about some examples of this kind of tampering. But as Jason said, I haven't really heard of any kind of high profile, right? Incidents of, data being tampered with to that, training data that leads to some actual malicious goal. Right.
I wonder if part of that is because most of the models that we currently work with they're more like public models that are used by the general public, rather than, because you can build mission specific models as well. And I think that would be a really interesting case there for an attacker if they gain access to that source data, if they could totally mess with the training. In that case. I just think like a riot, like it's like not industrial espionage, but industrial sabotage, really.
Yeah, absolutely. I mean, there's the concept too of, right, if you have a business adversary that knows kind of where you're sourcing your data from, can start to try to poison that. You triggered a memory, or you jogged my memory rather. There was there's been, I think there's like some ongoing work. So if you're not familiar with Hugging Face is like the de facto model hosting hub. It's kind of like GitHub, but for machine learning models.
All the open source ones.
Yeah. And apparently there's been at least 100 or so instances of malicious models that have been uploaded to that, right?
Oh, really? Okay.
Right. Yeah. And so this kind of comes into that again. We'll talk about the supply chain of, it matters where you get your base model from too, right? Yeah. And so validating the sources. And one, this is a bit of a tangent, but one issue I have with the current state of things is we have all these models that are open source, right? In that here's the model, but oftentimes you don't have access to the data it was trained on, right?
Yeah.
And the models themselves are very difficult to interpret.
I was going to ask next, because it's not like you can like open the file and search for certain strings or something.
Right,
like that.
right.
That's not really going to work.
It doesn't work like that.
Yeah.
And because the data that's contained within these models is in the form of what's called an embedding, which is a numerical representation of the tokens, right? So it represents essentially the semantics of things, right? So it's not one-to-one parity of the data, but it's the semantic meaning. But out of that, you can still, right, potentially get malicious behavior, right? You could still get sensitive data output, right? But it's, you can't easily just interpret those model files, and they're generally massive as well. So there's a lack of transparency on the training data that causes troubles. There's some proposed solutions to that we'll also kind of touch on. But yeah, so again, it kind of comes down to this. It's like, if you think about, in a way, I mean, you ideally wouldn't just use some random GitHub repository, right? For whatever.
You have to vet it first.
You have to vet it.
You can't really look at the code. So
yeah, exactly. So it makes it more troubling. So you do have to rely, like at this point, there's more reliance on making sure the model is from a trusted organization, right? Because there's nothing really stopping me from taking Meta's Llama 3 model, right, their base model, fine tuning it to generate backdoored code, right? Yeah. When a certain type of project is asked to be generated, and then re-uploading
a bunch of web shells.
Right, exactly. And then re-uploading that to Hugging Face, and maybe I did something else to kind of improve the model a little bit too, so people want to use it.
Yeah.
And so we have a similar issue in terms of supply chain to, more typical software supply chain, except we have even less visibility and it's more inscrutable. So it's kind of a scary problem. Also, not to mention that a lot of times the kind of still, a little aside, a lot of times the way these work is the models are published with some additional Python code that is executed. So like when you use the Python transformers library, there's a flag in there for execute code, true or false. It's false by default. But a lot of models need some additional like code to be ran when that model is loaded. And that's often published with the model on Hugging Face. So you can see that, but you can see the code, but oftentimes you have to think about, how often are people actually, validating that? That's also an important component of it. Well, let's jump ahead. We talk about the, let's just go through an overview real quick of the OWASP LLM top 10, which I highly recommend, familiarizing yourself with. In fact, I'm going to put a link to the actual page that OWASP has in the chat.
I found that it's hard to paste links into this sometimes.
Let's see.
You might have to. Oh, there we go.
There we go. Yeah, I think sometimes it tries to safe link it or something, right? Like yeah. This is a good site just to even keep an eye on, because they link out to some additional resources too that are more geared towards, I'm adopting generative AI technology in my organization and I need to know what to be concerned about, right? Whereas the top 10 is kind of more of it's good for a broad overview, but it's not necessarily actionable information, right? But looking at this, right, we have right at the start kind of, I think, the biggest one, right? Prompt injection, then insecure out, which prompt injection, just a quick, detail on what that is, or, that is where an attacker is able to influence the behavior of a model in some manner through not the training data, but through the prompt that's given to the model, right? And so you have two kinds. Generally, you have direct, which is where I can ask the model directly to do something it shouldn't do, right? And it does it. And I bypass some safety measures or whatever. Then there's indirect, which, going back to the RAG example that Jason gave, where you have documents that a model can fetch and then use as context to answer questions about them. You have to be considerate of what's in those documents and who can modify them or upload them, because it's possible then to maybe slip malicious instructions to the model into those documents, such that when it loads one as context, it then interprets that as an instruction to do something it shouldn't do. Again, depends on the context. But maybe it has access to, an API that for some reason it has its own its own token for, and
okay.
Yeah, it's kind of, again, it depends on that. Where is that model and what is it allowed to do within the system? But that would be indirect prompt injection. And then we kind of get to the thing, one of the big ones that we're focused on today, which is the training data poisoning, and model denial of service, which is really any kind of denial of service of the system. This sort of could be application level, but it could also be there's instances where there are certain tokens and strings that some models will, essentially, it'll trigger them to kind of like repeating it infinitely. There was a sort of famous one, like a little while back with ChatGPT. I'm forgetting what it was. They did fix it, but you could ask it to repeat a certain sentence, and it would then repeat it ad infinitum, and essentially that's like burning up OpenAI's resources. And so you can think if you get that slipped into an AI or an API driven prompting system, right? Now you've kind of locked up that part of the system.
I mean, we already know that even just making a single request to an LLM and having it process that and bring back a response, that's fairly intensive.
It's very resource intensive.
Exactly.
There's some interesting work going on in trying to make LLMs or even small language models less resource intensive. It's actually something that I'm doing a lot of work on as like a side project. So it's an interesting space, but it's a very difficult one. Yeah. And then we talk about supply chain vulnerabilities, right? Which we kind of already touched on a little bit. And then sensitive data disclosure. This gets its own thing in the top 10, but some of the issues that arise from training data poisoning, for example, and supply chain issues could result in, for example, sensitive data disclosure.
I can't think of a situation where you would have sensitive data disclosure that wasn't related to one of the other ones already.
Right, exactly. And I mean, you could again, if you have a model with agency, right? Again, this could fall into the excessive agency. A model has access to too much API surface, right? And you're able to prompt it to give you information about another user. An example kind of from my own experience pen testing systems, right, is essentially, right, a common thing is to have now is starting to be more common having like a Gen AI chat assistant within the application. So just without knowing the architecture is trying to prompt that to see, okay, well, can this thing tell me, it can tell me details about my own account, right? My own orders or something of that nature, right? Does it have access to other people's in a way that I can prompt it to tell me that? And again, that would still fall potentially under like prompt injection, right? Possibly excessive agency. It's the thing I find with these sort of lists and security, right? You can't really box things in too well, right? They don't fit into just one category neatly all the time. It's usually multiple things that apply. Insecure plugin design. This is kind of, again, I could see this maybe being excessive agency as well. But if you think about if you've messed with ChatGPT, for example, you can install plugins, right? I don't know if they have it in free now, but I know in Pro, you can install plugins that allow the model to do other things, right?
Integrate. Mostly just interact with an API, right? Unless they change it.
Yeah, it's mostly. Mostly seems like it's interacting with an API. I think the way it kind of works is, right, it's going to call out to whatever thing that that you've written code to do something. Right. It's just going to trigger that. And so that really falls into, did you write that plugin securely? Is it
to me that feels like that's you're at a point where you're outside of the scope, unless there's some way for that.
Yeah,
I don't know.
The only thing I guess I could see is maybe like a lot of the times the way these are integrated with the models is using prompt context, where you describe what the method call should look like, right? And what values are allowed in there. Maybe that's an insecurely designed interface between the model and the plugin, but that's still, it's kind of blurry. I agree. It's more in the realm of the code is bad, right? It's not necessarily related to the LLM. To me, that's kind of like saying, a normal web app, the user is insecure because the web app has a cross-site scripting vulnerability or something, right? Like it, but it's in there. That's so we don't always have to agree with what OWASP says, I guess. Yeah, we have excessive agency. That's essentially the model is capable of doing more than it should be able to for the intended purpose of the design of the application. Over reliance. This one's interesting to me in a way that it's an interesting kind of it's not as, I guess, technical or clearly definable as some of the other ones, right? But you have over reliance in the sense of if you're using generative AI applications to aid with business decisions, for example, right? Using the output of that without proper oversight and proper scrutiny would kind of fall into over reliance. So this is more of like a policy, procedure, people-y thing, right?
Yeah. Okay.
Because I mean, they produce incorrect results frequently.
Do. Yeah, and they're very convincing results. Though. That's the problem.
Exactly. Yeah.
It looks like this should be right.
Right. It's very convincing, and I mean, the amount of times I've asked like ChatGPT to write some simple little script, and this happens to me a lot. It invents a package, right, that doesn't exist, and then starts using it, and I don't know that. So then I have to go and look, does this exist? Or I'll say, no, use this package, and it'll make up method calls. And that's even worse.
That too. It's like these method calls exist in other packages, so they must also exist in this one.
Right.
It doesn't tell you that. Yeah.
So that's just, important to be aware of. Or, for example, writing this webinar, right? I was like, well, I'm going to use ChatGPT to expand on some ideas. And I often use generative AI or, as the way I often use it, and I think this is a really effective way to use it, is kind of like a sounding board for my own ideas.
I use it too that way, like just for brainstorming. That's like, exactly. I have this idea. Let me just go back and forth with the AI a little bit and help me develop the idea.
Right. And oftentimes I find that it comes back with a bunch of bad ideas, and then I'm like, that's all terrible. Now I have a good idea though.
Yeah.
But for this, it made up. I asked ChatGPT to go look at the URL for the LLM top 10 and design some headings and stuff, and it just started making up entries in the list, and I'm like, these are not even correct. But somebody could, it's totally within the realm of possibility.
I could see that. I could see like so many things I can think of where people might consider, an LLM should be really good at this. Like here's one, sanitizing data. Yeah, sure. No, don't do that.
Don't do that. Model. So we'll move on, but the last one is model theft. Model theft is kind of interesting. I would like to do so let me take a step back. The prompt injection blog post is actually a part of a series that's ongoing, where I will be doing a blog post on each of these topics from the top 10. The model theft is an interesting one. It's pretty general, right? It's theft of the model itself in some manner. That could be by compromised credentials to wherever you're hosting the model, right? But there's some interesting techniques that have been sort of discovered where essentially researchers were able to abuse an amount of automated prompting using other LLMs to extract the weights of the model. But it's not a 100% thing. Like they could extract it partially. Oh, really? Yeah.
Okay, so you're not talking about like stealing the files that
no
model. No, you're talking about actually.
So stealing the file would fall under this, but there is also another technique that's been developed where,
like, you're basically reverse engineering it, sort of.
in a way, yeah.
Through
So
prompts? Is that
through prompting, right? So it involves you query the LLM with a large number of prompts on like a particular topic.
Oh, interesting.
And then those outputs can be used to fine tune another model. And so what you're essentially doing is weaponizing knowledge distillation, which is a valid technique for training smaller, more performant models from larger models.
Okay.
Yeah. So like if you have, the reason this becomes kind of a problem is if you think about, it's not as much of a problem for like, here's a base model that's very general, right?
No.
But if you have a model that you have fine-tuned with proprietary data and knowledge, right?
Yeah, and let's say you spent months actually getting it tuned that way.
Spent months, lots of money. It's now a product your company offers, right? It's a part of revenue. And so if now I can go and essentially replicate your model just by querying it over and over again, that's hitting that IP theft in a way.
Yeah, that's what I was thinking. It's like yeah, exactly.
Which is a very interesting problem, right? And preventing it is kind of preventing that is kind of right.
Well, I guess you would prevent that by having controls limiting how much.
Right. API rate limiting.
Yeah.
Request, those kind of rate limiting and things like that.
Yeah.
While that theoretically wouldn't stop it, right? Like how rate limiting on an API doesn't theoretically stop enumerating IDs or brute forcing, right?
Mm-hmm.
It's practically infeasible, right? Yeah, exactly, Fausto. It's like it's like if you ask me a bunch of questions about, I don't know, another client and I didn't have a filter, or something, and I just told you all that, or something like that, right? Or you asked me a bunch of questions about how I pen test and I gave you all that knowledge, and then you went, I don't know, you went and became a pen tester or something. It's kind of hard to come up with the analogy, I think.
It's not it doesn't really work with people as well, I think.
Yeah.
But yeah, I kind of get what you're saying.
Yeah.
We should move on to the next slide, I think, because
I think
your next one, you're actually digging into more details on the data poisoning. So,
exactly. Yeah. But those are interesting points. Like it's an unexplored space. So yeah, we're going to talk about the third one though in a little more detail, right? The model training data poisoning, right? And so what this is the manipulation of pre-training data or data involved in fine tuning, right? Or data used in embedding processes. So you brought up the RAG stuff before, right? So you were saying I knew more than you, and I was like, I don't know about that, because you get it, right? That process too, right, involves data that influences the model in some way, and so that falls into this whole data pipeline that we have to think about, and that data can be poisoned. And again, as I mentioned, right, this can result in biased outputs. Which that sort of thing can, result in reputational harm for a company, or, bad decision making if these models are used, to inform, humans that are now making decisions on things.
Well,
falsified outputs, which again kind of falls into that.
Consider one of the biggest use cases for LLMs that companies actually use these days, like right now, which is they have them driving their chat bots on their websites. So you're asking for help on their products or services. And if that somehow got poisoned along the way, then how's that going to help your what's that going to do to your reputation?
I mean, if I could even poison it to like when somebody asks the model, the chatbot about, foo product and how to use it, it instead responds with a blurb about bar and you'd link to it or something.
It's like, oh yeah, we don't do this very well, but you should try this other company over here.
Right.
It's like, whoops.
All the way to just the model having bad data. I mean, it could output offensive things even, right?
That's true too, yeah.
And that has a similar
like
effect.
You remove the guardrails basically.
Right.
For vanity and whatnot.
And falsified outputs, again, this is This is different from what is commonly referred to as hallucinating. Although I have some strong opinions on that use of that term for what is the model making things up. I don't know if I'll get into it, but there's an interesting paper that maybe I'll link to at the end of this. Essentially, the models, they don't have perception, and to hallucinate is to misperceive something, so they can't actually hallucinate, and that's essentially attributing consciousness to the model when it's not.
Yeah,
it's more of a philosophical thing, though. But I think the biggest, back to the data poisoning, right? The falsified outputs is different from hallucinating in that you could think of it as like the example I gave earlier about a model that was, trained to distribute misinformation about topics, like deliberately attempting to be incorrect, that sort of thing. It was trained for that purpose, essentially, but to be convincing. Manipulating that data maybe to scrub, political information out or something, right? Or incorrect political, facts and things of that into a model. That sort of thing could be very impactful if abused. And the further we integrate these sort of systems into our society, the more that starts to become a pretty big risk. But the more, I think, technical and concrete impact is model backdooring, where an attacker is trying to attempt to influence the training of the model in such a way that there's some kind of phrase or topic that, when asked about it, responds with a very specific thing, right? And so if we jump, I have an example of this, but we're going to talk about real quick. We'll talk about the supply chain vulnerabilities and how those, play into this data pipeline as well.
And we already talked. We've touched on this several times already. So
right. So we just kind of go through it real quick. Right. Again, I mean, we're looking at using pre-trained models. This is often what is done. You grab a pre-trained model because it's very expensive and time-consuming to pre-train a model yourself, and that's usually supplied by some third party. Those third parties are vulnerable to attack as well, right? Where did they get their data from? Oftentimes we don't know because they don't publish that information. I'm looking at you, Meta, and then you say it's open source, yet you have a weird license. Anyways, they have a license on their model that's like, if you build an application with it, has over like 700,000 concurrent users or something like that, you have to then get a different license with them. It's like, fine, I get it. It's just that's not open source. Like, again, more, I guess, philosophical stances on things. Right. So that company, that third party, they're vulnerable to supply chain issues. Right. You could go and grab a backdoor pre-trained model on accident. Like I mentioned earlier, there's nothing really stopping me from making my own backdoored version of, GPT-2 or Llama or Mistral or whatever, right?
Well, I think that's the exact same problem as container repositories.
Right.
You download a container.
It is. It's very similar, right? We have this concept. Essentially, what we have is this concept of generalizing that a little bit. We have the concept of like poisoning artifacts in a way, right? Because you think about what's a pre-trained model? It's a file of weights, right? What's a container? It's a file of layers of other files and stuff, right?
Yeah.
What is a dependency, a software dependency? It's a file hosted somewhere as well, right? So these are all artifacts that get used in other systems, right? So we have this, it's very similar. And so some of the solutions to that, some of the protections are similar to things we already know. For example, and this is in another slide, but hashing, model hashing, right? We have, and we also have software bill of materials. There's ML bill of materials, which highlights the data that's used, the sources, and sort of the custody of them and things like that. An example that I've dealt with personally, use of poisoned crowdsourced data for pre-training or fine-tuning, specifically fine-tuning. I have a project where I'm crowdsourcing data. I have to, and specifically the downstream use is to generate code, right?
Hmm.
So, yeah, my solution to that is that contributions are just manually reviewed by myself through a pull request.
I guess if you don't do that, you're gonna you're gonna end up with essentially you're training it on the average.
Yeah,
Like the average coder, essentially. If it, let's say you have a model that's trained on code that you've gotten from somewhere like GitHub. If what you do is just train it on all of it without any sort of looking at it as it goes in, then effectively what you're going to end up with is the average, which not every developer's equal.
That's a really good point. Somebody I watch on YouTube every now and then was kind of talking about their programming, channel.
Yeah.
And they were sort of talking about, Copilot and ChatGPT and stuff generating code and whatnot.
A good example.
Yeah. And people being like, oh no, are developers, like there's this narrative of like, is software engineering dead? Should you even bother learning to code anymore? And it's clickbait stuff, right? To get views. But this person was essentially saying the same thing. It was like, it's just going to get the average. Like the average developer's not very good. So if the model replaces you at this point, at this current generation of what the technology we have,
then you're average.
Then you're average, and maybe like do better. Yeah.
That's not very nice way of putting it, but yeah, I can understand that argument.
And we have output of sensitive data, right, or copyrighted content that was erroneously included in the model training data.
There's a lot of that. That's especially on the artistic side of things. There are a lot of people who are very upset about
absolutely
that aspect of things. Because what do you do when you have a model that's out there, that's already being used, it's already been distributed, it's already being used as a base for other models? It's like you can't like undo that training. Mm-hmm. You have to remove the model and start over, basically, don't you?
There's like a degree of, there's some techniques that like you can edit the weights, but that's not really tenable at this point. It's kind of, the cat's already out of the bag on that one. And a lot of these big companies are like, they have pretty blatantly violated tons of copyright, at least in my opinion, and many others. And it's like, there's no accountability. Like, it's like, oh, oops, oh, well.
It was on the internet. It's fair game.
Yeah. Like, okay.
No.
Yeah. On that real quick, I had this idea that I saw something recently that kind of popped up about this, but I was talking with my partner. She's a professional artist. She's an illustrator. So this is a big deal for her. And, I was like, well, what would you like to see? Like, what if there was essentially these models come out with like a certification of ethically sourced data, right? That could be one approach, and there's some movement towards doing that. And then I was like, and also, I mean, I kind of think it would be interesting to see like a marketplace where artists can get paid to produce training data, right? I don't think every artist would be into that, but
no,
right? Some would, right? At least as a fair, like, because this is not going to stop. It's too late. Anyways, that's a total list side. There's so many little threads to pull out with all this stuff. But I wanted to, look at kind of this diagram here that I think, for me at least, illustrates how I think about this problem of, our data pipeline, right? And so we have a couple pieces here, right? We have over here on the left, this third-party model supplier, right? They've built a pre-trained model. Now, they got data from somewhere for that, right? Whether they scraped the internet or they crowdsourced it or whatever, right? So they're susceptible to an attacker potentially poisoning that data, right? Then we kind of go over to here where, okay, we're thinking about building an application. We pull down this pre-trained model. This model maybe didn't have a ML bomb, right? A machine learning bill of materials, right? So we have no idea what data was used, whether it was tampered, potentially tampered with. Is it hashed? Do we know? Does it match, right? No, we're just going to pull it, we're going to use it. We're going to trust this third party, right? And so now we want to fine tune this model on code, right? That's on the internet. It's fair game. We're going to go scrape GitHub, right? For code, right? And I see a question there, and I'll get to that in 1 second. That's a good question. So we have, model fine tuning. We're going to go and grab code from GitHub, right? And we're just going to scrape it because it's a lot of effort to kind of actually go through and see like if it's good quality code or if it's malicious or anything. So we start fine tuning the model on that, right? That's a mistake because we didn't vet those sources. And then we deploy the model into an inference system, right? And let's say we have a chat application that lets us ask for code generation, right? So we say, build my microservice. Well, maybe this attacker started poisoning data by making a bunch of repositories that matched kind of what they knew your company was, training this model on, or they're just trying to lay traps essentially for LLMs, right? Almost like squatting, like typo squatting or something, right? Like you're LLM data squatting, right? With poison data that when asked for, I don't know, a JavaScript authentication service or something, right? It inserts a little line that logs that, the auth details out to some URL, right? And so now or it's trained on a bunch of web shells and it starts trying to, starts injecting web shells into the code, right? And then we deploy that code that our model so helpfully generated for us, but oops, we deployed, potentially a web shell, right?
Yeah.
And so that's just sort of, I think, an example that highlights like the worst case, in my opinion.
Yeah.
And this is, again, I mentioned I have a side project that's like essentially this, where I am taking a pre-trained model that I have to like very meticulously try to vet. And
well, the other thing I think is worth pointing out on this, I think this diagram is fantastic.
Thank you.
But it's actually a simplification of reality.
Yeah.
More than one way, because, for example, the fine tuning, my understanding is like these are layers. It's kind of like with containers again, right? So you have pre-trained model, you might fine tune that, and then you may have somebody who grabs the fine tuned model and then further fine tunes that one. And so you have that happening. And the same thing with code that's generated. It then gets put in something that's actually used as a dependency in other things that use it as a dependency in other things. So you have this sort of cascade.
Yeah, exactly. It cascades out. There's the potential for it to just propagate.
Yeah, one problem in one part of this could just cause problems throughout the rest. Yeah, it's really interesting stuff.
Yeah, and it's a tough security problem. I mean, it's a similar problem to like what we as an industry have already been struggling with, which is, dependencies and supply chain stuff. It's hard.
Yeah,
it's very difficult
problem to solve. Really, it's a various different controls working together that get you past that, not one.
Yeah, absolutely.
Silver bullet, right?
So Fausto asked, do you think that asking for the ML bomb could be something you could ask for as a part of contract negotiations? And I think, yeah, I mean, right, that fits in my opinion, with negotiating a contract of if you have a company, you're going to use their model, maybe they're supplying a model for you, or you said, hey, we've got this data, we need you to fine tune a model for us. They supply it, right? What base model are they using? Do they have, a bill of materials for that? What data was it trained on? What assurances can they give you that it's, trained on vetted and sanitized data?
Yeah. What you don't want to have is a model that you're going to use somewhere in the public face, for example, and then find out afterwards that it was trained on a whole bunch of copyrighted material that you're supposed to.
Exactly.
So that makes you look really bad.
Exactly.
And that would be an innocent use. That's not even intentionally malicious. That's just being,
right. And it's a thing with a lot of this too, is like, it's not all the risks are not all intentional, right? It's not all necessarily a hacker out there executing some grand scheme to poison, a bunch of models. A lot of it too is just problems of, in a way, like negligence of, the way these models are getting trained. I don't necessarily, the base models.
Well, let's face it, it's a race, right? This is a
Yeah.
everyone's
Yeah.
trying to get the better model out faster, and so they're not paying a whole lot of attention to
Yeah.
that rule.
One thing is, if you look at if you haven't, I do recommend just kind of browsing the Hugging Face website. One thing that is common on there is the models are published with model cards. And I've started to see smaller kind of projects and stuff actually start to publish, like, oh, by the way, here's the data set we used and here's a link to it, right? And you can look at that data set yourself, right? So also validating that, right? I become skeptical if, and it could be an enterprise thing, right? Maybe it's a private model that you're negotiating use of. But they should still be able to give you some kind of assurance, right? Of here's what we, train this on. So yeah, let's see. Now let's talk about some just general like best practices real quick.
We're gonna have to go through these quick because we're running low on time.
Right. So we already mentioned the ML bomb, right? To maintain data attestations, right? Verify the supply chain of that training data and the pre-trained models. That's a little different than the ML bomb because you may not have that, but if you can see what data was used, right? If it's just a link out to it, ML bomb is a specific like standard, right? That's kind of being pushed. Fine tune models to your specific use case, right? This does allow you to kind of fine tune things down in case like this model was trained on, the internet was scraped, right? Well, fine tune it down to whatever your specific use case is. This reduces the chance that it's going to output something, unsavory, unintentionally, or copyrighted, right? You can also fine tune guardrails in, right? Review that training data collection process, right? If you're fine tuning, review that process to make sure like what sources you're gathering data from, right? And leverage that strict data vetting, input filters. There's some advanced techniques too. You're looking for statistical outlier detection. People have trained LLMs to be able to point out what would potentially be adversarial or bad data, right? So these are techniques too to kind of help scale this out and automate it. And that would also kind of fall in this ML SecOps, right? Which is a new term because we've got to have a SecOps for everything, right?
For everything, yeah.
But an interesting one is this auto poisoning technique, right? And this is to include adversarial robustness into the training process. And this is what I kind of mentioned with like guardrails. What this essentially is you train a version of the model and then you generate adversarial responses using adversarial prompts, and you collect that into a new data set. And then you essentially label those as these are adversarial, prompts and responses and things like that. And then you fine tune the model again so that it then becomes, it's able to understand what an adversarial prompt is.
It's kind of like just an inoculation, right? So
it's, yeah, exactly. It's I like that. And then there's LLM red teaming, right? And vulnerability assessments. A little different from like what we think of as red teaming, pen testing. This is more like testing the model for guardrails and malicious output and things like that. There's some interesting tools related to that too, for like fuzzing models. Leverage human in the loop techniques. This is what I've done in my own projects. It's very effective. It's just, it doesn't scale very well, but if, not everybody is working at a massive scale necessarily, right? So it may be feasible to have, more reliance on that manual person intervention to validate things, right? So that's worth thinking about, right? You may not need to jump for those advanced techniques that let you scale out horizontally, to, the size of like Meta or something, right? And then leverage model and code signing, right? So these models can be signed just like we have with other types of artifacts, right? If they come with a signature, you want to validate that before you execute the model. And again, this is more policy related, but you want to review the data supplier's terms and conditions, what their license is, right? What their privacy policies are. Make sure that aligns with your goals, right? That could be where did they source the data? Was it copyrighted material, etc. Right? So yeah, I mean that's kind of the brain dump high level of, you know,
this was really good.
How to think about protecting against this.
Yeah, no, this was really good. I really appreciate this.
I'm glad. Thank you.
So
it's a fun topic. It's just there's so much I could say. Like we could just talk and talk. So
yeah, well, I know you have more down the road. I think that you were talking about doing as well. So I think we'll definitely have more sessions on AI. Maybe cover some of the other top 10 from the LLM top 10.
Yeah, absolutely. I definitely plan on it.
So for those who joined us live, your CPE should be sent automatically. But if you have any issues with that, go ahead and let Jeannie know. We have upcoming webcasts. I'm just going to list these off very quickly. Cloudy with a Chance of Stealth on July 11th. On July 26th, we have Cybersecurity Frameworks in the Octagon, which is a panel. And then on the 9th of August, we're doing DARE-inspired strategies for engaging developers, which will be Jennifer on that one. So great. I'm going to go ahead and stop the recording.